Let's go through these real quick. On this first one, I don't know, I haven't done it yet. So limit x goes to -5 from the right, 1 minus x squared over 5 plus x. All right, so first thing you do, you got to see, what's happening, right? Let x go to -5. So on the top you get 1, let's just look at this, 1 take away -5 squared, right? So that's going to be 1 minus 25, right? -24, right? Isn't that what would happen? And then on the bottom, well, you get 0, don't you? And so what you have here is fixed, right? Fixed over 0. And the top is negative, right? The top is negative. And so the question is, are we approaching 0 from positive or negative numbers? We should know right now that the answer is either infinity, negative infinity, or does not exist, right? Those are the 3 possible answers. So let's figure out what's happening on the bottom. So I told you draw a number line, right? Put your point, what you're approaching, -5, and then approach it from the right side, right? So a number that would be to the right of -5? -4.9, something like that, not -5.1, right? -4.9. Think about what would happen if you took that number and plugged it in right there. You get 5 plus -4.9. That'd be a really small positive number. So this is going to be a small positive number. You have a negative divided by a positive, negative infinity. Okay? Questions there? All right, this one, you get infinity over infinity, right? So you're going to need to clear out the highest power of x in the denominator, so x to the 4th, but it's under a root. So what are you going to put on the outside? 1 over x squared. 1 over x squared. You could even do the square root of 1 over x squared if you want to do it that way. Or sorry, over to the 4th. It really is up to you. Okay, you could do the square root of 1 over x to the 4th, or you could just do 1 over x squared. And then you distribute that through here. You get 4 plus 1 over x squared over, and then when you push this in here, it gets squared, 1 over x squared. Sorry, it was x squared. It goes 1 over x to the 4th, and then when you pass that through these two, you get 9 plus 1 over x cubed. And then you take your limit, and then you get 4/3. This was under a root still. So the answer there should be 4/3. If you just give me the answer 4/3 without any work, I'm not going to give you full credit. All right? I need to see some sort of work. All right? I have to see what you did. Yeah. Okay, that's the quiz. Let's move on. All right? When's our first test? Thursday. Next Thursday, right? So a week from today. So my plan is to try and send out before the end of the week, which tomorrow I guess we'll say is the end of the week. I'm going to try and send you something so you can start reviewing for the exam over the weekend. All right? So expect something from me via email within the next 24 to 48 hours. All right? And then when we come back on Tuesday, whatever we do on Tuesday will not be on that exam. So today's material will be the end of what you will see on that exam, all right? All right, so let's continue. Do you all remember what we were doing last time? We started talking about trying to come up with a formula for the slope of the tangent line to some function, right? And we had this, that's not it. We had this kind of master formula right here. This was kind of our big takeaway from last class, that if someone gives you a curve, right? I'm going to put this over here, so we'll just leave this up here for the rest of the day. We said if you have some function, right, f, you go to some point A on that function, and you go up to the point on the function there, there is some tangent line there, right? We can find both the slope of that line. Let me make sure I'm good to go here. We can both find the slope of that line and the equation of that line, right? The slope of that line is the limit that's right there in that parenthesis, and then that's the equation of the line. So I'm just going to put this here. The slope of the tangent line is the limit as x approaches a of f of x minus f of a all over, pardon? 2.1. This was 2.1. That's right. So that's the slope of the tangent line, right? And then if you want the equation of the tangent line, then you're going to write y minus, and then just that formula there. F of a equals this. I'm just going to put m tan instead of writing that limit over, times x minus a. So I just wrote that formula right there, but instead of writing all this, I just wrote that here instead. All right, that's what we did. And I gave you a couple of examples. Do you remember the one we ended with? I believe it was f of x equals 1 over 2 root x. Look in your notes, right? And I wanted us to find the slope of the tangent line at x equal, or sorry, at a equals 4, right? So I said a equals 4, but then I gave you a bunch of numbers, and I said, what if I asked you to do it at all of these different numbers? Wouldn't that be a pain in the butt, right? So what I like to do now is I like to say, let's find the slope of the tangent line at x equals, now I'm not going to tell you what the value of this is. I'm not going to say it's 4 or anything else. I'm just going to say at a, okay, at some arbitrary value of a. So we're going to run the formula. Let's figure out what the formula would give us. We have the slope of tangent line is equal to, all right, the limit as x approaches a of f of x minus f of a over x minus a. Right? That we burn into our minds now, right? We've memorized this formula because we're in Cal 1 and we're going to use it a lot. And we just need to replace things now, right? So limit, see, x is going to a. I'm not going to replace a with 4 like we did in last class. I'm going to just leave a as a. And tell me, what is f of x? Well, what's our function? 1 over 2 root x, right? Minus, what's f of a? So if you look back in your notes last class, we were actually plugging 4 in, weren't we? And if you plug 4 into that, you get a number, don't you? But here we're not plugging in 4, we're plugging in a. So if we plug a into that, what do we get? 1 over 2 root a. Okay. So see, it's a variable expression. It's not a number. That's okay. We're going to keep going. All over x minus a. See, we don't replace this a with anything. We would like to know what happens if you let x go to a in this expression. Now, if you just do it, let x, replace all your x's with a's, and what are you going to get? If that's an a, you get 1 over 2 root a minus 1 over 2 root a, so that's 0 on top. A minus a would be 0 on the bottom, you get 0 over 0, right? So we need some way around that, right? So we're going to need to somehow cancel something. Algebra, some sort of trick, right? So this right now, as it sits, is 0 over 0, right? This is bad. Oh, bad. So what algebra can we do? Do you remember this from last class? Someone asked. We were talking about this. Remember, this is a complex fraction, right? Right, you have fraction within a fraction. Do you remember what I told you to do? Put them together first. These two come together, common denominator. Let's get a common denominator between these two fractions, all right? So they both have a 2, don't they? Okay, this one has a root x, this one has a root a, which means this one's going to need a root a on top bottom, and this one's going to need a root x top and bottom. Let's do that. Okay, so limit x approaches a. Okay, 1 over, I'll use colors, that'll be cute. Okay, let's do, I'm going to multiply this by root a, right? And then I'll do minus, and I've got 1 over 2 root a, and this one's going to get the root x, right? Root x over root x. I'm completely allowed to do that because that's just algebra, and all I'm doing is multiplying each of those fractions by 1, right? All right, this becomes limit x approaches a. All right, when we put all those together, right, just multiply across the top. You'll get root a on top. And then the denominator will be what? You can say it several ways. How would you say it? 2. You could do 2 square root of xa if you want. X times a. So you could put those two roots together, root a and root x, since they're both square roots, you could put them together and put the a times x underneath the root, or you could keep them separate. Totally up to you. Is that all right with you? Mm-hmm. Okay, and then the other fraction over here, minus, becomes root x over 2, and then isn't the same thing under there? Root x times a. I could flip it. A times x, multiplication doesn't matter what order. All of that is divided by x minus a. Now the whole point of that was that these would have the same denominators, right? So now we can put them together into one fraction. Keep going here. Limit x approaches a. Okay, it's going to be root a minus root x over the common denominator, 2 root x times a, and then all of that divided by x minus a. All right, any questions up to that point? Where do you think I'm headed now? I mean, I did the first thing, which was complex fraction, get a common denominator. Now, what do you think?
Did you flip it, put it over 1 and then flip it?
Like this over 1 and then flip it? We could do that, yes, absolutely. And I'll do it. But let's keep in mind, what are we trying to achieve? We're trying to get rid of the 0 over 0, right? So we're trying to make the bottom, that 0 on the bottom, cancel with something. So we'd love for this x minus a to cancel with something up here, right? But I don't see anything that it can cancel with, right? Like this doesn't cancel with anything here. Conjugate, right? Think about it. This is a root minus a root. Conjugates have helped in the past. So I don't know, this is where this comes down to like your brain and like how far ahead can you see? I was in my Cal 2 class yesterday and they're starting to understand that like you have to see down the road pretty far in order to do okay with this. I mean, in Cal 2 especially. So you have to kind of see right now that if you do the conjugate of this, you're gonna get, what are you gonna get if you do the conjugate of that? You're gonna get a minus x, right? And then that's almost this. You're off by a sign. So I'm going to do it now. Here comes my conjugate. I'm going to multiply this by 1. So I'm going to do root a plus root x, root a plus root x. And I need to put it in parentheses because it's 2 terms, and I'm multiplying it by 2 terms. So what I did there in black was introduced a 1. And that way, hopefully, things will work out. Now, as far as writing this x minus a over 1 and flipping it, I'll do that maybe in a minute. I'm just going to take care of the conjugate now. All right, here we go. I'm going to try and work up here. Limit x approaches a. Okay, what's my new numerator? A minus x, right? This, all that stuff, that's just a minus x up there. We know that because we've done conjugate too many times now. Okay, below that, I have the common denominator, 2 root x times a. And then I have the conjugate down there with it, but I am not going to multiply that conjugate through. I'm just going to leave it. And then all of that is still over x minus a. Any questions there? These went together, and then I did this times this. I left this alone, and then it's all over x minus a still. I'll go ahead and do the next step. You can rewrite this as this over 1, and then You have a fraction divided by a fraction, so I'll flip it up. You don't have to do this step, but I told you all that what gets people in calculus is the what? Is the algebra, right? Are you seeing that? See, they're almost ready to go, right? They're almost ready to go. What do I need to do? Factor -1 out. Either the top or the bottom, your choice. So I don't care which one we do. Let's do the top one. I'm kind of running out of room here. Limit x goes to a. I'm going to pull a -1 out of the top. Oops. I could leave it like that. -1. If I pull -1 out, this becomes -a plus x, right? I'm going to write it the other way around. X minus a. That's all over the piece here that we had. And then I still have the times 1 over x minus a. All right. I think we're there. These go away. No questions? Come on. It's your education. We're good? Okay. Let's just, I'm out of room there, so I'm just going to write what I have left right here. Limit x goes to a. I was 2 for 2 yesterday from about this range. That's not going. Damn. It's 2 for 2. Yeah, that was it. Limit x goes to a. All right, what's on top? -1 over, and then on the bottom is just all this, right? Okay, so 2 root x times a parenthesis root a plus root x. There we go. We finally got it to a point where we don't have that x minus a on the bottom anymore, so we shouldn't have division by 0 anymore, right? Now we take the limit, let's let x go to a, see what happens. So I'm going to let all my x's become a's. So no more limit, -1 over 2 times the square root of a times a, right? A times a times a is a squared. So 2 times the square root of a squared, I'll write it. And then we have square root of a plus what? Square root of a again. Okay, this is -1 over, all right, that's just a, right? So we get 2 times a, and then what's root a plus root a? 2 root a, so times 2 root a. And isn't that just -1 over, let's see, 2 times 2 is 4, 4a root a? That would be an answer. We could also have, we could put these together, right? Because that's, I'll leave that. A times root a is the same as a times a to the 1/2 power. And now you can add the exponents, right? 1½ add to be 3/2. That's most of the time, that's the way you're going to see it, this way right here. So that's final answer. For this, the slope of the tangent line at x equals a is -1 over 4 a to the 3/2. Or, if you want, you could use that one. Okay? Look back in your notes from last class. When I gave you this problem initially, I told you to find the slope of the tangent line where? At x was what? At 4, right? And what was our answer? -1 over, it was it 32? Yeah. It was -1. Look, you can look in your notes and see that. It was -1 over 32. Do y'all see that if I plug 4, it's harder to plug 4 in here, but imagine if you plug 4 in for a right here. What would you get? 4 times 4, 16. Square root of 4, 2. 16 times 2, 32. -1 over 32. Right? Do you all see that the advantage of having a formula now is that now I can hand you any value of a. And you just go right to this. You don't have to do the limit over and over each time. So you only have to suffer once through the limit, right? And once you suffer once, then you have it for any value of a. So this is actually more powerful than what we did last class.
So, wait, is that the penalty?
This is the, well, y'all tell me, what is this? What does this represent? The what?
Like that master formula?
Yeah, but what is it? This is a formula for what? What does this give you?
Tangent line?
Not the tangent line. It gives you the what of the tangent line? The slope of the tangent line at x equals a. So now, like imagine we have just, that's our function. Let's just graph the function. Yeah, let's just graph the function. Oh shit, sorry, damn it. Okay, so let's graph this function. 1 over 2 square roots of x.
No, because I saw you write the 3 halves over there.
That's the same as this.
Yeah.
Yeah. So here's our function, right? If I were to go to, let's say, the value of 4, right there. Let me do something quickly. Give me a moment. This will be, won't take me but just a second. Is the algebra kind of intimidating you a little bit? Yeah. You're not alone. Y minus a equals f prime of a times x minus a, add a slider a. Well, oh shit, what did I do there? Oh, f of a. What the hell? So I just did something real quick on here where I can have the computer graph that tangent line for me. So see me moving this along here, and I'm getting that tangent line on the curve at different points. Yeah? A comma f of a. There's a point so you can actually see it. Okay, so when we went to the value of 4, right, for our x value, the slope of this tangent line is what? What's the slope of this line, this blue line? What's its slope? Negative 1 over 32. Negative 1 over 32. Let me move my x value over here to 1. What's the slope of that tangent line? My x value there is 1. What's the slope of that tangent line? How are you going to get it?
Negative 1 over 4.
You're going to plug 1 into this, right? Plug 1 into this. So if we plug 1 in here and 1 in here, we just get negative 1/4. That's the slope of that line, negative 1/4. Following? Hey, what happens as a gets bigger? So as we go out to the right in that graph, as a gets big, look at what happens to the slope of the tangent line. As a gets big, what's happening to that slope? It's flattening out, isn't it? It's getting almost horizontal. So as a gets big, you move out the right side of the graph. Think about what happens to this expression when a gets big. It gets closer to 0, which matches what's happening there, right? What about when a gets smaller, closer to 0? So imagine the denominator here gets smaller. We would have fixed over 0, wouldn't we? Which is either infinity or negative infinity, right? What can you tell me from the graph? Look at as x gets closer to 0, what's that slope doing? It's negative, but it's becoming almost vertical. And so you can see that it's becoming like negative infinity, right? Are y'all seeing the connection between these things? It's important to see the visual connection between that formula and what's happening on that graph. Let's do another one, okay? This was kind of like, I threw you right into the fire. This algebra is not fun, all right? But it's a good, like, welcome to 2.1, all right? Let's do an easier function. So here's the function for this example. I'm going to give you the function. Let's go with x cubed minus 2x squared, all right? And what I'd like for you to do is find the slope of the tangent line at x equals a. So I want you to give me basically a formula that will always spit out the slope of the tangent line for some given value on the function, some given x coordinate, right? Let's do that for, let's say that this is part A. Part B is I want you to find the slope of the tangent line at x equals 1. For part C, I'd like the slope of the tangent line at x equals -2. And then for part D, I want to know the equation of the tangent line at x equals -2. So these are all different things. First thing, I want you to give me a general answer that's going to give us a formula for the slope of the tangent line at any point. Then I'm going to ask you for the slope tangent line at 2 points. So you're just going to use the formula that you just created, right? And then the last one is to go one step further and give me the actual equation of the tangent line, not the slope, the actual equation of the line that's tangent to the curve at this point. Understand these questions? No questions over the questions? So where do we start? What's the first thing I should write down?
Limit as x approaches a.
Yeah.
Of
Let's write the definition of the slope of the tangent line, right, at A. This is the limit as x approaches A. F of x minus, I'm going to write the formula first. So have y'all ever seen that movie Kill Bill 2?
Yes.
Yes? You know if you haven't, don't worry about it. But if you have seen it, you know when she's training in the mountains? Right? Who's seen it? Just a few of you. Okay. Okay. You know when she's training in the mountains and she's like waking up middle of the night like punching the wall because she's like so like hardcore training? Like she's sleeping? You should be waking up in the middle of the night spitting that limit out. Okay? No, you shouldn't. But I'm just saying, if you do it enough, like, I mean, you're embedded in this, right? I mean, that's the way it should be, right? It should be. Maybe not, maybe math isn't your favorite thing, but whatever you wind up studying, that's the way it should be for you at some point. All right, so here we go. That's the general formula for the slope of the tangent line at some point A. And now what I need to do is replace f of x and f of a with whatever they are in terms of this particular function, right? So this is slope tangent line equals, you know what? Let's make our lives just a little bit easier just for this first one. Let's make this, just take the power down once on these. Just make that one x squared and that one x for our first example. Keep it kind of nice. All right, so we changed the function. Is that okay? All right, so what is f of x? X squared minus 2x. Okay, subtract from that what? F of a, right? What's f of a?
a squared.
A squared minus 2a.
You gotta make plus 2a.
But you're subtracting it, right? You're subtracting the entire function at a, which means you have to put a parenthesis around that, which will distribute and become a plus. All over x minus a. Any questions there on where any of that comes from? F of x minus f of a. All over x minus a. It's always x minus a. That's the formula on the bottom. All right, distribute this negative sign through. This negative right here in this parenthesis is one of the biggest mistakes I see in students. They forget the parenthesis. They forget to distribute the negative. And then things are never going to work for you that way. All right, so this becomes limit x approaches a. All right, we have x squared minus 2x minus a squared plus 2a on top, and on the bottom we have x minus a. Now, check for yourself. Let's do it mentally. If you now replace all the x's with a's, what do you get? 0, 0. Guess what? It's going to be that every single time. Okay? That's the whole idea of the slope of the tangent line, is we're going to get 0 over 0 initially. We're going to need to do some algebra though, some sort of trick, something to make this better. Right? So this right here does give you 0 over 0, right? That's bad. So now we're going to continue limit x approaches a. All right, what sort of algebra can we do here? Oof.
Combine like terms in terms of the power. So like x squared minus a squared minus 2x plus 2a. And then you can pull the 2 out.
You want me to put the x squared minus a squared next to each other, and then you want me to put what? The minus 2x and plus 2a like this?
Yeah.
So you're just rearranging things.
Yeah.
Are you allowed to do that, everyone? Is that a legal algebra move, just to move things around? Okay, I'm willing to do it if it's legal. Now what?
You can pull out. Yeah, you can pull out a.
What can you pull? Can you pull anything out?
Oh,
You can't pull anything from all of them, right?
no, but from the x squared minus a squared, you can pull out an x minus a, right?
From these two, you can do what?
Pull out an x minus a.
Pull out an x minus a. That means you would have to factor this. So does everyone see a difference of squares there? Okay. I'm just following the leader here. Okay. This may or may not work. That's true, right? That's just the first two terms. Okay, and then we have over here minus 2x plus 2a. That is correct. I agree. I'm happy with that. No laws of algebra have been broken at this point. You're almost there. There's one more thing.
Pull negative, or pull a 2 out of the x plus a.
Pull a negative 2
Negative 2.
out of the last two terms. See, these two terms both have a 2. One of them's negative, one of them's positive. Do y'all see what happens if you pull a negative 2 out of both of these? Let's see. Isn't that what you would get if you pull a negative 2 from here and here? You get this. Think about if you distribute this through here and here, you get those two terms. Is this feeling unnatural? A little bit? Do y'all see that this has an x minus a and this has an x minus a? So you can pull out an x minus a from both. All right, let's pull an x minus a out. I'm going to use a bracket.